You're only going to hear my voice because my internet connection's a little slow at this moment, but I would just like to extend a warm welcome to all of you for attending our Learn at Lunch webinar series. My name is Megan Dettenmeyer. I'm the Utah State University Forestry Extension Educator, and part of my job is to facilitate these webinars that occur once a month. And I actually really enjoy finding speakers like the two we have today that can offer such regional and localized perspectives on important topics like this one. So to stay updated about future webinars, please feel free to write down this link, forestry.usd.edu, subscribe. I send out about 2 emails per month, just keeping our constituents up to date on local events. 12th with Rachel Carter from University of Utah. She's going to be talking about aspen. So our first speaker is Dr. Kevin Potter. He's a research associate professor at North Carolina State University. Many of you get Barbara Conkling's monthly newsletter from the Forest Service, and I ran across that newsletter last year, and Dr. Potter's research sparked my interest, so I reached out to him and he was graciously accepted an invitation to give a talk today. He's going to be talking about fires, beetles, and droughts and the National Forest Health Monitoring Program. Our second speaker is Sandy Wilmot from the Forest. She's a forest health specialist and climate change program coordinator from the Vermont Department of Forest, Parks, and Recreation. And the same situation happened. Barbara's informative newsletter brought Sandy's work to my attention, and she's going to be talking about forest trees and why they were dying in Vermont. So without further ado, I'm going to stop sharing my screen and hand it over to Kevin. Bear with me for a second here.
Okay, can you see and hear me?
Yeah, that looks good, Kevin.
Great. So, as Megan said, my name is Kevin Potter. I'm in the Department of Forestry and Environmental Resources at North Carolina State University, and I'm talking today about recent status and trends from the National Forest Health Monitoring Program, which is a part of the U.S. Forest Service. So, as we all know from the newspapers and sometimes just from looking out the window, that our forests are besieged by many different threats, beginning with forest insects and diseases, some of which are exotic, including the emerald ash borer, thousand cankers disease, which is doing a number on walnut species across the country, and some are native, including mountain pine beetle. Wildland fire is, as we all know, a major threat to forests, especially in the western part of the country. These are all photos from the 2014 Happy Camp Fire Complex in northwestern California, which burned in the neighborhood of 130,000 acres, which is, and we're having fires that are increasingly common at that size. We have severe weather events, as we know, ongoing drought in California, for example. Invasive plant species. These are some of the bad actors that we run across in this part of the country here. You can't throw a rock in the woods without hitting Japanese honeysuckle or Chinese privet here in the south, for example. And we have forest fragmentation and conversion, which is a serious problem. So the conversion of forest into non-forest state, whether that's agriculture or more commonly development, housing complexes and strip malls and that sort of thing, and the fragmentation of intact forests into smaller and smaller parcels of forest that don't have the same sort of value that intact forests have. So in light of all these threats, the U.S. Forest Service has the Forest Health Monitoring Program, which is a national program that's designed to determine status changes and trends and indicators of forest health on an annual basis across the country, and it uses data from ground plots and surveys, aerial surveys, and other biotic and abiotic data sources, most of which are publicly available. And it also develops analytical approaches to address forest health issues that affect the sustainability of forest ecosystems. And one of the main products or outputs of the Forest Health Monitoring National Program are national reports that the program produces on an annual basis. There have been 15 of these annual reports beginning in 2001. You can see the web address at the top right there where those things are available. And these present status changes and trends in forest health indicators on a national and multi-state regional scale. So I'm going to talk about some highlights from these reports and the kind of things that you can find in them. First of all, the production of these reports is overseen by the Eastern Forest Environmental Threat Assessment Center, which is a part of the U.S. Forest Service Southern Research Station based in Asheville, North Carolina. And the editors of that report are myself and Barbara Conkling, who you've heard about already. We're affiliates of the Forest Service at North Carolina State University, but we're actually stationed with the U.S. Forest Service in Research Triangle Park, North Carolina. And the contributors to these national reports include folks from many different parts of the Forest Service, including EFETAC, Forest Health Technology Enterprise Team in Fort Collins, and folks from the Forest Inventory and Analysis Program across the country. The NC State affiliates of EFETAC, Bob, myself, and Mark Ambrose, a research assistant, and then scientists from universities and from state and federal agencies across the country. So these national reports have three objectives, which are related to the design of the FHM program, which you see here. So the initial stage of monitoring essentially is detection monitoring, which uses national standardized surveys to evaluate status and change in forest ecosystems, and that comes in the form of satellite detections, aerial surveys, ground plots, and surveys across a broad scale. And then that information, as I'll talk about later, is used to then identify specific locations where there are problems to do additional research, evaluation monitoring, and intensive site monitoring. And then also the report presents research on monitoring techniques. So I'll talk first here about detection monitoring results that we show in the national report. So every year in the report we have 4 standard chapters that are repeated annual analyses of new data that we bring in, or that we have come into us. The first of those is the National Assessment of Insect and Disease Activity using Forest Health Protection National Insect and Disease Survey data. We have a national assessment of large-scale patterns of forest fire occurrence using MODIS satellite data, national fine-scale assessment of drought conditions using PRISM climate data, and then a national assessment of tree mortality using FIA data. So when we're doing this, we run up against what I call the drinking from the fire hose problem here. It's a big data challenge. Since about the year 2000, the U.S. government has collected all of these wonderful standardized fine-scale forest health data across the country, so wall-to-wall, usually at very fine scale, or in many cases at very fine scale. So what do we do with that information to make that useful for monitoring and for management, for policy making, and that sort of thing, both across space and across time? By way of example, this is a map of the satellite detected forest fire occurrences from last year, from 2015. Each one of these dots is represents a 1 kilometer pixel where fire occurred for one day in 2015, and there are literally tens of thousands of these. So you can't just present this map to policymakers and expect them, and managers and others and expect them to know what to do with it, right? So what do? One thing we can do and often do in our report is to summarize that information by region, often by county, sometimes by county, but often by an ecological region. So the U.S. Forest Service has a nested hierarchy of ecological regions that are increasingly similar to each other in terms of climate and soils and plant community as you get smaller in scale. So this is one of the smaller scales, ecoregion section, and this is the number of forest fire occurrences that are occurring per amount of forest within those ecoregion sections. This is for last year, And this is for the Forest Health Monitoring Report that will come out later this year. So this is a work in progress, and you can see that last year there was an awful lot of fire in the northwestern interior part of the country, as well as along the northwest coast of California. This is another example. So this is work that Mark Ambrose does. And this is presenting the ratio of annual mortality of woody biomass to growth in woody biomass. So this shows you places where trees are dying faster than they're growing back. And in this case, those are places in the places where that is most an issue in the eastern U.S. are in the upper Midwest, the western part of the upper Midwest, the plain states there. So that's good and useful. But we're also interested in identifying sort of fine scale locations that are statistically significantly clustered for a given phenomenon, forest health threat. And we do that using what we call the spatial association of scalable hexagons method, which was described in a paper published earlier this year, where we divide the country up into a hexagonal grid here, and then get the mean value for a phenomenon, whether that's the number of fire occurrences or the amount of forest that's experiencing mortality from insects and diseases. So in our little outset map here, so we get the mean of that value for each of the hexagons in there, and then we compare that to the country as a whole, controlling for variation and the difference between the means of our neighborhood and the whole country, and use a moving window approach to find out places where we have statistically significant clustering of that phenomenon. So this is an example. This is aerial survey data from the Forest Health Protection Program. On the right here, this is a map that shows the FHP surveyed area in 2014, and on the right, so these are places where people have been up in the air, in airplanes flying around and sketching out places where they've seen mortality on the ground and assigning a value or assigning a cause for that. On the left here, these are the leading agents of mortality for those that they found, starting off with mountain pine beetle there at the top. So what do we do with that kind of information? We do this hotspot analysis. So these are hotspots of forest mortality in 2014, and we can look at the causes of or the agents that cause these different hotspots. So we can see in 2014, mountain pine beetle was causing an awful lot of mortality, as it has for several years in the interior part of the Pacific Northwest. Spruce beetle has been a major problem in the Rocky Mountain states, Colorado, Utah, and New Mexico in recent years. Fir engraver really exploded last year in Arizona and California. Sudden oak death, there was a hotspot of sudden oak death mortality in California, and then in Wisconsin there was a hotspot of emerald ash borer mortality. So now we'll do the same thing with agents of defoliation. So our leading agent of defoliation in 2014 was spruce budworm. And we can see several hotspots of spruce budworm mortality in the Great Lakes states and then the Rocky Mountain states as well. There was a hotspot of defoliation associated with jack pine budworm in Michigan, winter moth in the Massachusetts area, gypsy moth in Pennsylvania and West Virginia, and then bald cypress leaf roller was an issue in Louisiana. So we do that same approach for fire. So these are geographic hotspots of wildland fire for 2014 and 2015, and you can see how those change from one year to the next. And you can see in 2014, this is the Happy Camp Fire that I showed pictures of from before. So we're not only interested in looking at sort of trends in space, we're also interested in looking at trends over time in these forest health threats. And this graphic here shows the number of forest fire occurrences by year since the MODIS satellite started operating in our first full year of data in 2001, you can see there is a definite upward trend. This red line is the whole country. The blue line is the lower 48 states. You can see there is definitely an upward trend in number of forest fire occurrences over time. So we can use that kind of information to quantify excess or deficiency of fires, for example. So these are places for 2015 that had, the red locations here are places that had more fire than we would expect given how much fire they had on an annual basis for the previous 14 years. So there were several of those places in Pacific Northwest, the Great Lakes states, and the Northeast. And then these blue locations are places that actually had less fire than we would expect given how much fire they have had on average over the previous 14 years. So Frank Koch in the Forest Service does a similar kind of analysis using PRISM climate data. So these are locations here where in 2014 there was extreme drought, the redder areas, and excess precipitation, purple and blue areas, compared to the 100 years before that. So very useful and interesting information there. So those are analyses of sort of annual analyses that we present every year in our report. We also include analyses of longer term trends. These are one-off things often. Recent examples include a national update of forest fragmentation indicators from Kurt Ritter's, some output from the 2013 to 2027 National Insect and Disease Forest Risk Assessment from Frank Christ and folks in the Forest Health Technology Enterprise team, a detailed assessment of the decline of core forests in the U.S. by Kurt Ritter's again, and then invasive plants on forest land in the United States by Chris and Sonia Oswald in FIA. So just a couple of quick examples. So if we look at the 2015 FHM report here, we can see trends in forest fragmentation between 2001 and 2011. So the bluer a county is here, the more of the greater loss it has had in the amount of forest over that time. But more troublesome, there has been a greater loss in interior and intact forest cover area during that same period, and that's pretty much across the country. This shows a map from the analysis of invasive plant species occurrence from FIA data. So we can see here the percent of FIA subplots that had invasive plants on them, and you can see in the Southeast and the Midwest that most plots had at least one invasive plant on them. So our second objective in the national report is to present new techniques for analyzing forest health data and new applications of established techniques. And I'll show just a couple of quick examples of that that have been published in the last couple of years. One of these is monitoring forest disturbances across seasons using the forewarn recognition and tracking system by Steve Norman and other folks in the Southern Research Station, working towards an integrated approach for monitoring forest disturbance at multiple scales and frequency. This is Jim Ellenwood and folks in Forest Health Technology Enterprise team. And then climate effects on lichen indicators for nitrogen by Sarah Javon in the Pacific Northwest Research Station, the Forest Service. So this is a figure from the chapter that Jim Ellenwood and his colleagues did describing the forest disturbance monitor that the Forest Health Technology Enterprise team, or FHM, uses to identify locations that are experiencing forest decline, disturbance in various ways. This is a figure from the chapter by Steve Norman and others in the Southern Research Station using satellite detection, change over time in normalized differential vegetation index, or NDVI, to show disturbance related to many different things. In this case, this was forest disturbance following Hurricane Sandy after it slammed into the northeast coast up by New York. And then finally, the FHM reports include results from FHM-funded studies of problem areas. So we do our detection monitoring work here. Locations are identified that have specific problems and that need some additional intensive site monitoring. The FHM program provides researchers in the Forest Service and universities and in the states to go study those in more depth, and that's actually what Sandy Wilmot, the next speaker, is going to be discussing. One of these projects that was funded by the evaluation monitoring program. So this is a list of the evaluation monitoring summaries or fairly fine scale summaries that were included in the most recent report, the 2015 report. I don't expect you to be able to read these, but this shows that every one of these reports has in the neighborhood of 8 to 12 to 15 of these summaries, fairly short, 5 or 6 pages summaries of the work that folks have been doing at a fairly fine scale to investigate what is going on related to some of these specific forest health threats that have been identified using the detection monitoring approaches that I talked about before. So to summarize, the FHM national reports have 3 objectives: presenting information on forest health status changes and trends from a national or multi-state regional perspective, presenting new techniques for analyzing forest health data, presenting results of recently completed evaluation monitoring projects, which is what Sandy's going to be talking about, an example of that. And these are timely, peer-reviewed sources of information on forest health issues and indicators, and that are produced through cooperation between North Carolina State University and the U.S. Forest Service, specifically the Eastern Forest Environmental Threat Assessment Center. So if you are interested, and I encourage you to be interested in looking at some of these reports, these are all online. If you go to this website here, FHM.fs.fed.us, you go to the FHM webpage, click on publications link on the left here, and this will bring up this page. These are all the completed reports. The 2015 report, we have a draft of it online. We're actually, the final version is very close to being finished, and all through the publication process through the Southern Research Station, so we'll have the final version of that up shortly. And the draft of the 2016 report we should have up by the end of the year or early next year. So to Ms. Possibly Barb Conkling, my co-editor on these reports, she handles the evaluation monitoring part of this. These are the authors of the chapters that I talked about here. Lots of technical assistance and review work. We're funded through the FHM program and through EFETAC, and we get data from many different locations or many different organizations. So if you're interested in contacting me, I'll be happy to try to answer questions later. My contact information is down here, and I also encourage you, as Megan mentioned before, there is a monthly update email from the FHM program that talks about publications, meetings, job opportunities, funding opportunities, all of that related to forest health. So I would encourage you to send Barb an email at the address below here if you would like to get on that list and to receive those monthly emails. So from there, I am done for now, and I will now hand it over to Sandy Wilmot.
Well, good afternoon. Am I unmuted?
Yes, you are. You sound and look good, Sandy.
Okay, thank you. Well, like archaeologists digging among among ruins, our forestry group was attempting to unearth why we suddenly had so much mortality standing dead trees. It was a mystery that really required collective efforts from a number of different tree sleuths. And the effort initially was led by Robert DeGuss in our Vermont Department of Forest Parks and Recreation, who then retired. Randy Morin from the U.S. Forest Service FIA branch, and Lindsay Watkins at the University of Vermont, a graduate student. So our charge was really to find out why trees were dying in Vermont. First off, you should understand that in Vermont, we have 75% of our land cover forested. So every community is nestled within these woods, and any kinds of forest decline are really pretty obvious to a lot of people. And they're valued for a number of reasons, many economic. In addition to beauty, we use our fall tourism to really highlight Vermont and its forests. With 85% of Vermont being privately owned, it's important for us as sleuths to figure out what's going on and try to understand if it's a one-time event or if it was something that was going to continue and cause more serious declines. This mystery started in 2008 when our FIA data showed a spike in the number of dead trees per acre, a real hike from about 5% to over 20% dead trees per acre. And it wasn't just unique to Vermont. The FIA group found similar trends in adjacent states. So keeping with my sleuth we needed to find out where the trees were dying, the scene of the crime, the victims, which tree species, the suspects, was it insects, diseases, weather related, and using some facts that we had, a host of forest health data. And I think I'm really fortunate to have had Kevin just introduce you to all the different tools that are used in Vermont and across the nation looking at forest health. Here in Vermont, we do fly the state every summer to look for areas of forest damage. These are mapped and recorded digitally so that we can overlay them with other data sets to better understand what's going on in the forest. We also have several networks of plots where we monitor forest health annually and periodically, looking at tree damages, crown health, growth, regeneration, and a number of other forest metrics. So we approached this mystery by looking at our existing forest health data, worked with Randy Morin to create some additional spatial layers that could look at site and disturbance factors and how they might have been related to the mortality. And then involved our graduate student in some field assessments to really look a little closer at what was going on and understand whether or not this was something that was going to continue or just discrete events. When we looked at our FIA data across the state, this mortality was really pretty well distributed. Here, the orangish and yellow colors were our percent dead trees. And although there's a lot of green there, you can see that there's spots of high mortality throughout the state. The span of time we were looking at was 1997 to 2007, which was between the two FIA surveys where we get our understanding of what was going on. The different tree species involved were really varied: red spruce, paper birch, balsam fir, red maple, American beech. And although white ash wasn't picked up in the FIA data, we'd had observations of mortality and decline, so we included that in our project. Each of these species in the FIA data had an increase in the number of standing dead trees. The suspects, there were a lot of them. The 1998 ice storm seemed to be the most obvious. We had droughts in 1999 and again in the 2001 and 2002 season. There was spruce winter injury that may have been affecting red spruce, forest tent caterpillar defoliation, beech bark disease, a number of stand replacing windstorms, balsam woolly adelgid, a non-native. Some air pollution effects may have been part of it with calcium depletion and nutrient availability. And with everything in our forests, the past land use and harvesting activity could well play a role. And with climate change, we just didn't know how that was interacting with some of the other variables. So briefly, what were we looking at? The 1998 ice storm coated many trees in the state, created dead trees, trees without limbs, and this was mapped across the state so that we could use that data layer in relation to where the mortality was. But overall, our ground surveys, like the Hardwood Health Survey, had showed us that tree recovery was really pretty quick following that storm. We had an initial about 15% mortality, but that had been considered in the FIA data already, so it would have been any additional mortality following the ice storm. Some of the species that did look bad were beech and paper birch. Throughout this 10-year period, we did see some drought effects, especially on shallow soils. We saw brown leaves, early leaf drop, signs of dieback. Our aerial survey maps give us a pretty good picture of where that was serious, in that the symptoms were severe enough so that we could map them from the air. Certain species seem to be affected more. Birch dieback and mortality was really statewide. These graphs show you from aerial survey the acres of damage of birch in the yellow and of spruce and fir in the green. This is especially true at the upper elevations. And during this period, we also had a number of stand replacing windstorms. You can see in 99, in 2007, but the acres affected tended to be very discrete, somewhere in the 3,000 to 8,000 acres. In our Vermont Monitoring Cooperative plot network, we visit the plots annually and could look at individual species and the timing of the decline. So for balsam fir, here we're looking at trees with high dieback. So it's only those trees that seem to be declining. And initially through the 90s, we saw balsam fir improving condition, but then that changed around 2001. Likely related to when we experienced the drought periods. Whereas with birch, we initially saw some effect in 1999 and then again in 2002. So it may have initially started with the ice storm and exacerbated with some of the drought conditions. Combining all of our different defoliators and biotic damages in our aerial survey, we could see that, yes, 1998 did affect a large acreage in the state, but really we started to see a trend more in 2002, 2003, and on into the end of the FIA period of 2007. during that period, we saw tremendous areas affected by forest tent caterpillar outbreak. For example, in 2005, much of southern Vermont was affected, and this photo shows you the type of total defoliation that was being seen in the southern part of the state. Much of these areas were able to recover, and we didn't see the kind of mortality you might expect given the FIA data. During this period, we also saw an increase in mortality and declines from beech bark disease, which tends to be exacerbated by drought conditions. We also included some analysis of air pollution types of injury. We have data from ozone bioindicator plots around the state, and we're able to get the concentrations of ozone from our state air quality people to look at really a dramatic decrease in the amount of ozone we're seeing in the state, and likewise the amount of injury on sensitive plants like white ash. So that was our existing data, and then Randy was able to take the FIA data, all the plot data, and you can see here the green are the unaffected plots and the yellow dots are those that had high mortality, and overlay our aerial survey maps, a whole host of different iterations of them. What you're seeing here really illustrated the involvement of beech bark disease in the mortality for the beech species, at least. On the plots with the FIA plots that are yellow showed beech bark disease, and it affected the growth pretty significantly. Randy also generated a host of precipitation-related maps and coupled them with layers like soil dryness index, soil depth, other site characteristics that might have been related to the effects of drought. And overall, we didn't see any really significant correlations between where we were seeing the mortality and this low precipitation event. So we considered that it likely was a secondary factor in a lot of the mortality that we saw. Then our graduate student did these field assessments at sites around the state. The different colored dots are related to the different species that were in decline at different areas. Here you see some of the sites that were present on these visits, trees in decline, some past logging injury affecting the tree trunks, and some diseases that were creating low vigor trees. Part of the assessment was looking for things like armillaria root rot, balsam woolly adelgid. Tree cores were taken of live trees, of declining trees, and we were not able to take cores of dead trees. We found a lot of internal decay on those tree cores, which made it a little difficult to analyze them. For white ash, we took samples and sent them for analysis to figure out whether ash yellows disease was involved, and really only one of the sites where we saw these epicormic shoots was related to ash yellows. For the most part, these sites tended to be on fairly wet locations where any kind of reduction in water might affect these shallow roots a little bit more. So when we put all of this together, and this is a very simplified version of what we found, we attributed the beech mortality to beech bark disease compounded with drought. So the beech bark disease can be there for many years, but it's the drought that really pushes the trees over the edge. White ash, for the most part, was drought related in that the roots were shallow, so that the impacts were greater when in these 2 drought periods that we experienced. Balsam fir, subsequent work has indicated that balsam woolly adelgid is really widespread in Vermont, and although drought was implicated in what we studied, it now is clear that balsam woolly adelgid has played a pretty major role in the mortality waves of balsam fir. For red maple, things were not very clear, but most of the sites that we visited had past logging wounds, and we know that red maple is not is very susceptible to internal decay from wounds. So that's sort of our conclusion there. For paper birch and red spruce, we had help from some colleagues here in Vermont who looked at the ice storm and soil calcium, and decided that the ice storm was the trigger for paper birch, and then whether trees survived or declined was related to whether or not they had adequate soil calcium. For red spruce, the spruce winter injury was the trigger, but again, on sites where there was low calcium, trees were not able to recover like the ones that had adequate nutrients. So that's the result of our study. I'd like to thank the Forest Service Evaluation Monitoring Program for helping support this work. And although it isn't always satisfying to dig up past evidence, at least we know that into the future, many of these declines are not going to continue, that they were caused by discrete events. So we'll carry on and keep our forests as healthy as we can. Thank you very much.
Okay, thanks, Sandy. We don't have any questions. I want to encourage, we're going to hang around for at least a few minutes, if not more. But I encourage anyone who has questions to use the Q&A pod to answer or to ask any questions. I'm going to also ask folks to hang on. At this point, I'm going to launch a short poll. And so right now, our viewers, you should see a poll in progress. It just popped up, and I'd ask you to just take a minute or so and answer the questions you see in the poll there. Also, if we have any brave souls, we are able to we're able to make attendees participants, and you can go live with your audio and video. So if we have anyone that's brave and wants to join the conversation, let us know inside the chat or the Q&A pod, and I can promote you to a panelist. Sandy, you can stop sharing your screen now if you like.
Hey, Mark.
Yeah.
I have a question for Sandy. So Sandy, you talk about red maple. Any trends with sugar maple?
Yeah, I didn't include that in this study, mostly because the FIA data had not picked up a jump in standing dead trees. That may be because they're really involved heavily in sugar making, so that it may be that a lot of the dead trees have been removed for firewood or whatever, but we haven't seen that kind of increase in mortality for the most part.
I see. Okay. There are some projections that should be happening under climate change, potentially. So something to keep an eye on, maybe? I don't know.
Yeah, definitely. We have a sugar maple plot network that we look at every year, and so we're trying to keep tabs on whether or not trees are declining.
Megan, we had a question in chat about ISA folks submitting for ISA credits.
Yeah, so if there wasn't a spot for entering your ISA CEUs or ISA number, feel free to just send it to me in a private email or in a private chat. If you push the 2, you can select just to send it to my name, your information. So, yeah.
Yeah, I don't know if you want to put your email in chat,
Sure, I'll put it.
If other folks know it. Let's see, someone raised their hand. Phil, does that mean you'd like to be promoted to a panelist? If you'll let me know in chat, I'll do that.
I would like to just say thanks, Sandy and Kevin, for taking time out of your busy days and busy schedule to create these presentations, because it's really nice to see your research come to life. You know, I can read about it in the newsletter, but it's nice to just put a name to a face and actually hear your interpretation of your studies, and it's helpful for me.
Happy to do it. Thank you for the invitation.
Mm-hmm.
Yeah, I see, Phil, you said that, and we actually had an issue with that. We'll take note of that for the next poll.
Well, I'm not seeing any more questions. So if there are not questions, maybe we should wrap it up.
Sounds good to me. Any parting comments, Kevin or Sandy?
I just encourage people to take a look at these reports. A lot of time and effort goes into designing these monitoring programs. So the FIA program, you know, we have 130,000 of these FIA plots across the country that are getting visited every 5 to 10 years. So there are field crews out there. We've got satellite data. We've got people flying around in airplanes, which is a fairly dangerous job, and there have been fatalities as a result of crashes and that sort of thing. So there's a lot of time and effort that goes into collecting this data and I encourage folks to take some time and see what these data are showing us about the state of our forests across the country, both at a large scale and a small scale.
All righty. Also, just let our participants know we've recorded this webinar, and Megan, I'll have it processed within a couple of days, and I'll pass that on to Megan, and I think she'll post that to the Forestry YouTube
Yep, I sure will, and I'm happy to type that in address into here. So yeah, it'll be up on the YouTube channel very shortly.
Okay. All righty. Thanks, everyone.
Thank you very much.
Have a good day.
Bye-bye.
You too. Bye.
Bye.